All right, so let me get started with the session on event-driven messaging with Schema Registry. So before that, let me give a quick introduction about myself. My name is Kasun Indrasiri. I'm a senior program manager at Azure Messaging team at Microsoft. So I have been working in the application integration and messaging space for a decade or so, and authored a couple of books on gRPC, cloud native patterns, and microservices. So in this session, I'm sharing my experience in event-driven messaging, and in particular, how you can leverage the schema registry in event-driven architecture. All right, so before I dive into the event-driven architecture and using schema registries in event-driven architecture, let me quickly talk about API specification for synchronous communication. I think most of you are familiar. You are in the API specification conference, of course, and you are familiar with the use of API specification to basically define your service interfaces and define the service contract and exposing that to your consumers. So, so basically, the key idea here is that you, once you expose those details to your consumers, consumers can actually use those information to send data, and all the data validation at the request level or response level happens automatically using the schemas that you specify. So now, once you have these schemas available, you usually expose them as part of the service definition. So it can be hosted along with the service, or it can be hosted in a separate service registry. So there are quite a few examples of such API specifications, such as Open API for RESTful services, ideal for gRPC, and GraphQL, and so on. So in all of these cases, we specify the schema track of the data that you exchange between your client and service applications. Now, when it comes to event-driven messaging, we are using structured data when it comes to events, right? So we use a particular business model and we serialize that data into that particular model from the producer side. Then you may deserialize it at the consumer side, and so on. So although we use structured data in event-driven or event streaming communication, we haven't been using schemas as compared to the synchronous request and response style communication. So, so one reason is usually the event data being produced to a central event broker asynchronously, and consumers often consume them in a completely decoupled and asynchronous way. So usually there is no contract being established between the producer and consumers for the most. But when it comes to dealing with structured data, we usually need to serialize the data that you write to event broker. So basically, as the producer, you use a schema, a local schema to serialize data to an event broker, and also at the consumer side, you can basically deserialize the content and start reading from the deserialized content. And then there can be multiple consumers as similar to this one, and they also use their own local schema. So the key idea of using schema dependent serialization formats is that you can have event data compressed into a serialized format, which is very efficient when it comes to representing data in the wire. So basically, you can drastically improve the performance when you use serialized data. Now, in this model, as you can see, we don't have a central place that we use to share or manage schema, right? So schemas are pretty much managed within the client application. So if you want to share the schema that you want to use, that you use for serialization, you may have to do that probably with direct communication from the producer and consumer. So now let's have a look at the reasons behind why we need a schema registry. Right. So when you publish some serialized data to a event broker, you usually need to have a schema associated with that data to deserialize it. Right. So that means you need to make sure that schema is available to your consumers. And especially when you are onboarding new consumers to the existing event streams, you need to make sure that new consumers understand the data that you publish to an event broker. So therefore, sharing the schema or sharing the schema in a central place so that the consumers can access in a typical event-driven or event streaming use case is quite critical. And we used to send, in this particular example, you as an alternative, you can send the schema along with each and every event that you publish to the event broker, right? So basically you publish the event data, along with that you package the schema content that is used to serialize the data. So that is obviously a very inefficient way of handling schemas. So therefore sending the whole schema with each and every message is not recommended. And also, when it comes to event streaming and event-driven communication, validation of the messages or events producers to the event broker, as well as the events consumed from event broker, is also quite critical. So we need to have some validation mechanism between both producers and consumers. And also, we deal with structured data, right? So we have to always need to make sure that the data that we use, the structure that we use, will get evolved with the business requirement. So therefore, your schema that you're going to use for serialization will evolve. For example, your consumer may use maybe an old version schema, while your producer is using a newer version of the schema. You need to make sure that there is a room to evolve schema. So by looking at all these requirements, that's where schema registries are trying to address these problems. So basically, what is offered as part of a generic schema registry is it's a central repository for storing all these different schema. Right. So so now we have the producer and consumer, and then we have the event broker. And now we have a separate repository of schemas residing in this schema registry. Now, once you have a schema registry, then you can always publish all the available schemas to the registry and make sure that producers and consumers access them when it comes to serialization or deserialization. In addition to that, within the schema registry, you can define associations or relationships between schemas. You can group schemas together based on the business or bounded context that you use. And also this uses the overage of sending a schema along with each and every message. Now you no longer want to send the schema to the consumer, rather you send a reference like a schema ID along with each and every event that you send to the event broker, so that your downstream consumers can obtain the ID and retrieve the matching schema from the registry. And obviously, schema registry can support different evolution or compatibility modes, so that producers and consumers can operate at different pace. And also, when it comes to event-driven architecture, in most cases, schema registries and event brokers are sort of decoupled, so that event broker primarily supports storing any type of data that is published and allowing consumers to consume them, while the schema enforcement and validation being offloaded to the producers and consumers. So if you look at the existing schema registry implementations, you will see you don't really enforce anything at the event broker level, rather you handle it at the producer and consumer level with the help of schema registry. Now with that, let's have a closer look at how the information or data flow works in a typical schema registry use case, right? So in this example, I have a Java application which uses Kafka as the producer, Kafka interface as the producer, and we assume that our broker can support different messaging protocols similar to Azure Event Hubs. Now here we have Kafka interface as the producer interface, and as part of the consumer interface, we have the MQP, and consumer is written using C#. So those are actually irrelevant for the usage of schema registry. But now let's take a scenario where you want to produce some data to the event broker, and as the first thing, you have the local schema residing in your Java application, and you use that schema to serialize data. So once you have the serialized data, you use the schema registry libraries as part of the producer. So this is just a matter of maybe configuring some properties, setting the schema URL and so on. Once you configure those properties, you can, the schemas that you use to serialize the data being used to use for a lookup, right? So the underlying client library send a request to the schema registry and conduct a lookup based on the schema content that you have and retrieve the schema ID. Now you have a reference to the schema that you use for the serialization. So if you don't have the schema available in the schema registry, you can also configure so that you can dynamically register the schema or dynamically publish the schema to the schema registry. Now, once you have the schema ID, now you have the serialized data, you have the schema ID, you basically prepend serialized data with the schema ID and publish that data to the event broker. And now from the consumer side, you can retrieve this data and you can identify the schema ID, and then you can do a lookup from the, again, from the client library is doing it. So you are doing a lookup based on the schema ID and retrieve the schema content. So once you have the schema content, you basically go and deserialize it. So that's the normal end-to-end information flow. So as you can see, obviously we don't want to do that for each and every message, right? That's why we have caching at both layers. Usually caching is being implemented as part of the SDK or client libraries that comes with the schema registry. Now, since you have some high-level understanding of how information flows within a typical schema registry use case, let's try to understand some of the concepts or some key elements of schema registry. So at very high level, we have schema groups element, which is sort of a collection, sort of a grouping of multiple schemas together. Again, these schemas may be created on a particular business context. So those things should be grouped under one schema group. So it's a named collection of schemas. And in a typical schema registry implementation, you can enforce different compatibility rules at schema group level. So the entire group share a single compatibility mode. And inside a schema group, you can have schemas. And a schema is obviously a description of the underlying data structure that you're going to use or that you will exchange between the producer and consumer. And schema evolves with the time, as we discussed earlier, and adhering to the compatibility mode that is defined at the consumer group level, schema group level. And so once you start changing or editing a given schema, it will create a new schema version. So one schema can have multiple schema versions. And when you start editing a given schema, you will be only able to change the schema, or you will be only able to save it as a new version only if matches the compatibility rule. And that's how schema versions are created. And when it comes to compatibility, that is where schema evolution happens, right? So once the initial schema is defined, you need to add maybe add new new records or new fields to that, or maybe you have to remove existing fields and update it, and so on. So therefore, Schema Registry supports this use case by this requirements by implementing compatibility patterns. So when it comes to compatibility, as I said earlier, when you update a schema, it creates a new version and it should comply with the underlying compatibility mode. And as part of the compatibility mode, we have 4 main modes. Basically, backward compatibility, forward compatibility, full compatibility, and no compatibility. And when it comes to backward compatibility, that means your consumer or your client application uses a newer version of the schema, but the data that is residing in the broker is old. So still the consumer can process them. Maybe consumer will apply default values for the new fields that it has, or remove or ignore any fields that are not there in the newer version. So similarly, forward compatibility means consumer code is using an old version, while the data residing in the broker is using the newer versions of the schema. So in that case, the consumer code will basically again ignore any new fields there in the event data, and also assume default values for the older ones. So full compatibility means you have both backward and forward compatibility. You have the both capability of backward and forward. And no compatibility means you don't really take care of the compatibility. So you need to handle compatibility at your client application level. Now, schema registry is a generic concept. It's not a vendor-specific technology. Therefore, standardization within schema registry interfaces is required. So currently, we have, as part of Microsoft, we have submitted schema registry interface to the CNCF Cloud Events under Cloud Events project, which is currently implemented as a working draft. And so this actually defines a standard and open standard for defining schema registry interfaces, how to retrieve schemas, what are the key elements of schema registry, and so on. So so the key idea behind this one is any registry implementation that uses this schema specification, schema registry specification, can interoperate with any other clients. So basically, for example, if you have a user client that can interact with, say, Azure Schema Registry, you can use the same code against another Schema Registry implementation. So there are multiple Schema Registry implementations available for event-driven messaging. So we have Azure Schema Registry implementation for most of the streaming use cases in Azure, as well as we have a Confluence Schema Registry, which uses their own proprietary interfaces. And similar to that, we have Google PubSub Schema Repository as well. So there are several other repository Schema Registry implementations, but these are the most popular ones that we have. Okay, so with that, let me quickly walk you through an end-to-end demo of using a schema registry. So for this use case, I'll be using Azure Schema Registry, as well as the Azure Event Broker, which is Azure Event Hubs. So a quick overview of the Azure messaging products that we have. We have, so primarily we have 3 main messaging products. So our main strategy is to have specific products to implement different messaging patterns. So we have Event Grid, Azure Event Grid, to support basically the push style distribution of discrete events. And we have Service Bus, which is a sort of a conventional message broker implementation. This can be used for implementing end-to-end guaranteed delivery scenarios using gate pull style, queue-based, transactional messaging. So that is quite popular for all the MQ style integrations. And then we have Event Hubs for big data streaming. So primarily similar to Kafka, you can use it as a multi-protocol broker that can ingest high volume of data and access them using different independent consumers using, again, pull style, like consumer cursor based access model. And so again, coming back to the event hubs, again, it's, as I said earlier, it's a multi-protocol engine. So in my example, I'll be using Kafka interface to publish data and consume data. So this is a fully managed service. You don't have to worry about scaling or coordination, redirection or anything. You just get a single endpoint, and you can publish data from multiple protocols as well as consume them from multiple consumer APIs as well. And again, Schema Registry, Azure Schema Registry is it's an implementation of the CNCF Schema Register spec. And currently it's been offered under Azure Event Hub's product as a feature of it. And so this acts as the central repository to store all your schemas. But it can be used universally with any Azure service or any other third-party messaging or event broker solutions as well. Now, the use case that I'm going to implement is with, again, I'm using a Kafka producer and Kafka consumer, and I'm going to use schema validation to implement this use case. And as a broker, I'm using Azure Event Hubs. Okay, so as the first step, let's get started with the schema registry. So now I'm inside the Azure portal, and this is my sort of the broker UI. And here I have set of topics defined. I'm using this demo schema registry topic. And inside my namespace, Event Hub's namespace, this is the sort of a workspace for implementing all your topics related to the Azure Event Hubs. So we have a schema registry entity. So when you click on the schema registry entity, you can see all the available schema groups. Okay. Now, again, this is a fully managed service. You don't have to worry about the operation or anything. So inside the schema registry, you can define different schema groups, right? So as part of a schema group, you can obviously give a name to the schema group and specify the serialization type and then the compatibility mode. So as I said earlier, one schema group share a single compatibility mode. Now inside a schema group, you can have multiple schemas. So in this case, I have 3 different schemas defined. So I'm going to use this particular Avro user schema in my example. So, and you can see there are multiple versions of the schemas available. So here I have only one version. I have deleted some of my older versions. That's why it shows there's 5. And now suppose I want to use this schema when it comes to my Kafka application, right? Now, let me show you the code of my Kafka application. So here I have a Kafka producer. This is my Kafka producer code. So in order to use schema registry, you only need to use this set of properties. So basically, this is your generic Kafka producer code. And then you have, you configure all these properties like the schema registry URL and whether you want to do auto registering or not, and some credentials and the name of the schema group that you're using, right? So schema, as the schema group, I'm using the demo schema group name that I configured in my Azure schema registry. So at the consumer side, that is again very simple. You have the Kafka consumer code, and in addition to that, you configure some schema registry properties, and all these packages are imported. You can see we don't have any apart from these 2. These are all generic Kafka and Avro related packages that we have used. Right now, let me quickly run the program Now from the producer side, I'm using a generic Kafka application, right? I don't need to do anything because Azure Event Hub's out of the box of Kafka API that it can interact with, right? And same thing applies for the consumer. So here I have a couple of options. Let me produce a generic record, right? Now, when you start producing data to Event Hubs, here the client library goes and fetch data from schema registry and make sure that that comply with the schema that we are publishing to, right? And also at the consumer side, you can do the same thing. You can see whether we can consume all these different information that we have just published. Consuming these all these generic records. Okay, now you can see all the information that I just published is available as part of consumer. So we don't really know whether we are using schemas or not, right? So let me quickly go and edit my schema so that I add a new field. Let me just edit it and add a new field. Okay, and now I am saving my schema here. I can see the diff, and you'll see different versions now. You can see 2 versions. Now let me start publishing data from my Kafka producer again. Now schema has changed. Okay. Okay, so I was able to publish data because I had this version available, right? Let me just go and delete data. I can try again. Okay, now you can see there it complains that I don't have the associated schema because this needs to have the data that I'm publishing needs to have the age property available. So so once I have the new schema included in my code, once I have my producer data comply with the schema, so I should be able to publish. But since we are running out of time, I'm not going into the other part of the demo, but you can also do the same thing using .NET as well. Here I have a similar example written using .NET. But in this case, you can see the schema registry SDK related code as well. So we create a schema registry serializer and a schema registry client. You go and fetch data from schema registry directly from your .NET code as well. All right, so I think with that, so we have a couple of information available here, some references to our SDKs of schema registry and some additional links. Thank you very much. So let me check my